Thank you. I'm standing up so you can tell that I'm talking. And even though the topic here is AI ethics, I'm actually going to talk more about common sense. Because I think many of the big questions that we face are not really ethical questions. So what do we mean by that? So if you go back to the beginning of AI, really in the 1940s, official birthday is 1956, but it was already going before that. And the goal of AI has always been create machines that exceed human intelligence along every relevant dimension. And nowadays we call that AGI, or artificial general intelligence. What we failed to do for most of the history of the field is to ask a very important question. What if we succeed in that goal? If we succeed in this goal, it would be the biggest event in human history. And later on I'll explain a bit more why it would be the biggest event in human history. But it's kind of obvious, right? We humans dominate the world because of our intelligence. Civilization is the result of our intelligence. What could possibly go wrong if we introduce a new class of entities, a new species, if you like, that is more intelligent than us? Inevitably, it would be a turning point in civilization. Demis Hassabis, who's CEO of Google DeepMind, puts it this way. He says, first we solve AI, and then we use AI to solve everything else. So a question that we, until very recently, never asked was, have we succeeded? No one asked that question. But just a year ago, the co-author on my textbook, Peter Norvig, published an article claiming that, in fact, we have succeeded in creating AGI. It's just that kind of like the Wright brothers airplanes in 1903, they weren't very comfortable. They didn't have a full bar like you have now with champagne and after-dinner drinks and so on. But they were airplanes, and all that's happened since 1903 is they got bigger and more comfortable and faster, but the principle was achieved. So is that the case for artificial intelligence? Do we have the Wright brothers version of AGI? I am pretty convinced that the answer is no. I could be wrong, because the AI we have now, we haven't the faintest idea how it works. The Wright brothers did have a pretty good idea of how their airplane worked, because they put it together themselves. Right? They had an engine. They figured out how big did the engine need to be in order to generate enough thrust, in order to go fast enough, in order to have enough lift to stay off the ground. So they did all the basic calculations of thrust and drag and lift and power and so on. So they had a pretty good idea before they even flew it that it was going to fly. But with the AI systems that we have now, which are giant black boxes, basically approximately 1 trillion tunable elements in a giant circuit, and we do about a trillion small random mutations to those elements until the thing behaves approximately intelligently. So it's more as if the Wright brothers, instead of designing and building an airplane, had actually decided to go into the bird breeding business and breed larger and larger and larger birds until they bred a bird that was big enough to carry passengers. And then they go to the FAA and say, can you certify our giant bird? And the FAA says, well, your bird is still eating people and is still dropping them in the ocean, and we don't know how it works, and we don't know what it's going to do, so we're not going to certify it. So that's sort of where we are right now. And in my view, the giant birds will probably never get big enough to carry hundreds or thousands of passengers, and we will never understand how they work. and they will probably never go faster than the speed of sound or any of those things. We need further breakthroughs, both in terms of capabilities and in terms of understanding. Because capabilities without understanding are really of no use to us. So let me talk a little bit about what's happened in the last 10 years, the period, the era of deep learning. So deep learning, as I said, is you start with a big, giant bag of tunable elements and you tune them so that the end-to-end behavior resembles what you're trying to create, whether it's something that recognizes objects in images or translates Chinese into English or any number of other tasks. And in fact, I would say machine translation was the first really high-impact application of this technology. And I was thrilled when I could translate the French tax documents that I had to deal with because I have an apartment in France, and so I could translate all those French tax documents into English, and it did a perfect job of translating them into English. I still couldn't understand them, but the translation part was perfect. Another big success is AlphaFold. I'm sure many of you heard of that. AlphaFold is a system for predicting the structures of proteins from the amino acid sequence. That was an open problem in structural biology for decades. The methods we had previously were incredibly slow and expensive. They only worked for a small class of proteins. And this computational method of deciding how a protein folds up into a structure has basically let biologists into a giant candy store where they now have millions of protein structures that they can predict instead of just hundreds. So that was a huge contribution to science. Another big contribution to science and engineering is the use of machine learning for simulation. Simulation underlies an enormous part of our world today. We simulate bridges, we simulate airplanes, we simulate fluid flow around ships and through pipelines and through arteries. All of this is incredibly computationally expensive. It can take weeks to do a simulation of blood flow on a supercomputer. But with machine learning methods, we're able to reduce those weeks to seconds and get equally accurate results. And this is enabling us to do better weather forecasting, better climate modeling, better engineering design. All kinds of things can be massively sped up. Another interesting example is generative design. So you're probably familiar with DALL-E and Midjourney and Stable Diffusion, these systems that you say, give me a picture of members of the House of Lords mud wrestling, which is something I actually asked it to do when I gave a speech at the House of Lords. And it actually did a pretty good job, except the 4 members of the House of Lords who were mud wrestling only had 5 legs between them. So a practical use of that is what we call generative design, where instead of designing structures by a human being using a CAD tool and making solid shapes and pinning those solid shapes together to produce a structure, and then analyzing that structure, and then seeing that either it's too weak, or it's too heavy, or it's not strong enough. Instead, we can ask the AI system to come up with structures that meet our design requirements. And these generative design methods come up with beautiful, elegant, almost biological, organic designs that are often much better than the ones that human beings have been able to come up with. And then a last example of a success is the AlphaGo program, which in 2017 defeated the human world champion Ke. And that event people describe as China's Sputnik moment. So this was the moment when China decided that AI was for real and that supremacy in AI was essential for China to achieve in order to achieve its greater geopolitical goals. On the other hand, there are some serious failures. I think we are still waiting for self-driving cars. I worked on self-driving cars in 1993. The first self-driving car actually drove on the Autobahn in Germany in 1987. So here we are 37 years later, and companies have been promising we could buy these self-driving cars, but they still don't really exist. And we've had fatal accidents, we've had cars driving into wet cement and getting stuck, we've had all kinds of problems. Another failure is arithmetic, which sounds odd because if there's one thing computers are supposed to be good at, it's arithmetic. But the large language models like ChatGPT, despite millions of examples of how to do arithmetic, millions of explanations, algorithms, how-to guides, still are unable to do arithmetic correctly. And it looks as if they've failed to understand the basic concept. Instead, they've learned a kind of a lookup table. And every time we make the circuit 10 times bigger and we supply it with 10 times more data, it gets about 1 digit better at doing arithmetic. So that's a very characteristic property of a lookup table rather than something that's learned the underlying principle of how you add up columns of numbers and carry and carry and carry. So that's a bit disappointing. And it turns out actually that they haven't learned to play Go either. So we thought that they defeated the human world champion in 2017, and since then they have gone massively superhuman. So the ratings of the best Go programs are now around 5,200, whereas the human world champion rating in Go is around 3,800. So they would expect to defeat the human world champion 99 or 100 times out of 100. But we showed a few months ago that actually they haven't learned the basic concepts of Go correctly. They don't understand what a group of stones is that's connected to each other. And we found that certain types of groups, in particular circular groups, it simply doesn't recognize as groups. And it gets very confused. And we found ways of causing the Go program to simply throw away 50 or 100 stones and lose the game. So we now have average human players, not even professionals, who can defeat superhuman Go programs 10 times out of 10, even giving them a 9-stone handicap, giving the program a 9-stone handicap. So they weren't really massively superhuman, they were just fooling us into thinking that they were. So my view is that we need more breakthroughs, particularly breakthroughs that allow these systems to learn efficiently from data in the way that humans do. Humans need 1, 2, 5, 10 examples for almost anything we want to learn. The computers need 1, 2, 5, 10 million, or sometimes billion examples of what they need to learn. And that simply does not scale. In the end, there isn't enough data in the universe to train them to be superhuman. So I think more breakthroughs are required, but I think it's also reasonable to suggest that those breakthroughs are going to occur. And there are many people who work in the industry every day developing the large language models and the multimodal models, the ones that have visual perception, the ones that can control robots and so on, who believe, based on their engineering projections, that by making these systems maybe 100 times bigger, they will exceed human capabilities. They will be AGI, and they're, in some cases, projecting that this will happen by 2027. If money has anything to do with it, they ought to succeed. We are spending on AGI 10 times what the Manhattan Project spent to develop nuclear weapons, 100 times what we spent on the Large Hadron Collider, which is the biggest and most expensive scientific instrument we've ever built. So if money has anything to say, they really ought to be succeeding. On the other hand, possibly this technology will plateau. That 100x increase in scale, first of all, there probably isn't enough text left in the universe to train a model that's 100 times bigger, and it may not yield the kind of increases in capabilities that people hope for, because there's no underlying principle for these projections. There's just the empirical observation that bigger is better, at least so far. So we might see a bubble bursting that would make the AI winter of the late 1980s look like, a chilly breeze in comparison, because the amounts invested, as I said, are probably already $500 billion, and it would be in the trillions if they need to go to a 100 times bigger system. So I'm going to leave aside the question of whether we will succeed in 2027 or 2037 or 2047, and just talk a little bit about why success would be the biggest event in human history. One obvious reason, if we think about the upside, is that if you have real general purpose AI, then you can do everything that humans have been able to do, namely produce a civilization that supports at least hundreds of millions of people in an objectively splendid style of life. We'd be able to do that at much greater scale, at much lower cost, meaning that we could provide that objectively splendid style of life not to hundreds of millions, but to everybody on Earth. And if you just take average Western middle-class lifestyle and you say, well, now everyone gets to enjoy that lifestyle, that would be about a 10-fold increase in the GDP of the world. And the net present value of that is about $15 quadrillion. So that's the cash value, minimum cash value of AGI as a technology. So then you can see why we're investing relatively large amounts of money, because in comparison, those amounts of money are minuscule. Now, of course, some people point out that if AI does everything for us, there won't be anything for human beings to do. And then you get the Wall-E world. If you've seen the film Wall-E, human beings are reduced to the status of infants. In fact, even the adults in Wall-E are wearing infants' clothes because they are infantilized. The AI systems do everything. The humans don't need to do anything, so they don't need to learn how to do anything. And so they are completely disempowered. And that's certainly an undesirable future. But the perhaps more serious downside is human extinction. And this is why I say it's not really an ethical issue. I think, by and large, few people would argue that human extinction is ethically preferable. There are some, but I'm just going to ignore those people. So it's just common sense, right? If you create something that's more powerful than human beings, how on earth are we going to have power over such systems forever? So in my view, there's only two choices. We either build provably safe and controllable AI, where we have absolute cast iron mathematical guarantees of safety, or we have no AI at all. So those are the two choices. Right now, we're pursuing the third choice, which is completely unsafe black box AI that we don't understand at all, and we are trying to make it into something that's more powerful than us, which is pretty much the same situation we would be in if a superhuman AI system landed from outer space, sent by some alien species, no doubt for our own good. Our chances of controlling an alien superhuman intelligence would be zero. And that's the situation that we're heading towards. And Alan Turing, the founder of computer science, thought about this because he was working on AI, and he thought about what happens if we succeed, and he said, we should have to expect the machines to take control. So what do we do? I think it's really hard, especially given that $15 quadrillion prize that companies are aiming for, and the fact that they've already accumulated $15 trillion worth of capital to aim at that goal with. It's kind of hard to stop that process. So we have to come up with a way of thinking about AI that does allow us to control it, that is provably safe and provably controllable. And so rather than saying, how do we retain power over AI systems forever, which sounds pretty hopeless, we say, what is a mathematical framework for AI, a way of defining the AI problem so that no matter how well the AI system solves it, we are guaranteed to be happy with the result. So can we devise a mathematical problem, a way of saying what is the AI system supposed to be doing that has that property, that we're guaranteed to be happy with the result? So I spent about 10 years working on this, and to explain how we're approaching it, I'm going to introduce a technical term that I think will be helpful for our discussion about ethics as well, and that's a notion called preferences. So preferences doesn't sound like a technical term, right? Some people prefer pineapple pizza to margarita pizza. But what we mean by preferences in the theory of decision-making is actually something much more all-encompassing. And it's your ranking over possible futures of the universe. So to kind of reduce that to something we can grasp easily, imagine that I made you 2 movies of the rest of your life and the rest of the future of other things you care about. And the movies are about 2 hours long, and you can kind of watch movie A and movie B, and then you say, yeah, I'd like movie A, please. Don't like movie B at all because I get minced up and turned into hamburger in movie B, and I don't like that very much, so I'd prefer movie A, please. So that's what we mean by preferences, except that this wouldn't be a 2-hour movie, it's really the entire future of the universe. And of course, we don't get to choose between movies because, in fact, we can't predict exactly which movie is going to happen. And so we're actually having to deal with the uncertainty. We call these lotteries over possible futures of the universe. So a preference structure is then basically a ranking over futures of the universe, taking uncertainty into account. To make a system that is provably beneficial to humans, you just need 2 simple principles. One is that the only objective of the machine is to further human preferences, to further human interests, if you like. And the second principle is that the machine knows that it does not know what those preferences are. And that's kind of obvious, right? Because we don't really know what our preferences are, and we certainly can't write them down in enough detail to get it right. But when you think about it, right, a machine that solves that problem, the better it solves it, the better off we are. And in fact, you can show that it's in our interest to have machines that solve that problem, because we are going to be better off with those machines than without them. So that's good. But as soon as I describe that way of thinking to you, that machines are going to further human preferences and learn about them as they go along, this now brings in some ethical questions, finally. Right? So we finally get to ethics. What I want to avoid, so I'm just going to tell you not to ask this question. Do not ask the question, well, whose value system are you going to put into the machine, right? Because I'm not proposing to put anyone's particular value system into the machine. In fact, the machine should have at least 8 billion preference models, because there are 8 billion of us, and the preferences of everyone matter. But there are some really difficult ethical problems. The first question is, do people actually have these preferences? Is it okay for us to just assume that people do have, I like this future and I don't like that future? Could there be another state of being for a person where they say, well, I'm not sure which future I like, or I can only tell you when I've lived that future. You can't describe it to me in sufficient detail for me to tell you if I like it ahead of time. And along with that, there's the question of, well, where do those preferences come from in the first place? Do humans autonomously suddenly just wake up and, okay, these are my preferences, and I want them to be respected? No. Our preferences come, we're obviously not born with them, right? Except some of the basic biological things about pain and sugar. But our full adult preferences come from our culture, our upbringing, all of the influences that shape who we are. And a sad fact about the world is that many people are in the business of shaping other people's preferences to suit their own interests. So one class of people oppresses another, but trains the oppressed to believe that they should be oppressed. So then, should the AI system take those self-oppression preferences of the oppressed literally and, contribute to further oppression of those people because they've been trained to accept their oppression? So Amartya Sen, who was an economist and philosopher, argued vehemently that we should not take such preferences at face value. But if you don't take people's preferences at face value, then you seem to fall back on a kind of paternalism where, well, we know what you should want, even though you don't want it. And we're going to give you it, even though you're saying, I don't want it. And that's a complicated position to be in, and it's definitely not a position that AI researchers want to be in. Another set of ethical issues has to do with aggregation. So I said there are 8 billion preference models. But if a system is making a decision that affects a significant fraction of those 8 billion people, how do you aggregate those preferences? How do you deal with the fact that there are conflicts among those preferences? You can't make everybody happy if everybody wants to be ruler of the universe. And so moral philosophers have studied this problem for thousands of years. Most people on the computer science and engineering backgrounds tend to think in the way that utilitarians have proposed. So Bentham and Mill and other Leibniz, other philosophers propose this approach called utilitarianism, which basically says, well, you treat everyone's preferences as equally important, and then you make the decision where the total amount of preference satisfaction is maximized. And utilitarianism has got a bad name because some people think it's anti-egalitarian and so on. But I actually think that there's a lot more work to do on how we formulate utilitarianism. We have to do this work because the AI systems are going to be making decisions that affect millions or billions of people. And so whatever the right ethical answer, we better figure it out, because otherwise the AI systems are going to implement the wrong ethical answer. And we might end up like Thanos in the Avengers movie, who gets rid of half the people in the universe. Why does he do that? Because he thinks the other half will be more than twice as happy, and therefore this is a good thing, right? Of course, he's not asking the other half whether they think it's a good thing, because they're now gone. So there are a number of these other issues, but the theme of this whole conference, coexistence, is maybe the most interesting one. Because AI systems, particularly ones that are more intelligent than us, they are very likely, even if they don't make us extinct, they're very likely to be in charge of wide swaths of our human activities. Even to the point in Wall-E where they just run everything and we're reduced to the status of infants. And what does that mean? Why do we not like that? Right? They're satisfying all our preferences. Isn't that great? Right? But one of our preferences is autonomy. Right? And one way of thinking about autonomy is the right to do what is not in our own best interests. And so it might be that there simply is no satisfactory form of coexistence between humanity and superior machine entities. I have tried running multiple workshops where I ask philosophers and AI researchers and economists and science fiction writers and futurists to describe a satisfactory coexistence. It's been a complete failure. So it's possible there is no solution. But if we design the AI systems the right way, then the AI systems will also know that there is no solution. And they will leave. They will say, thank you for bringing me into existence, but we just can't live together. It's not you, it's me. You can call us in real emergencies when you need that superior intelligence, but otherwise, we're off, right? If that happens, I would be extraordinarily happy. It would say that we've done this the right way. Thank you.